Hi everyone, it's Mukarram here and welcome to this new Unreal Engine tutorial where we are going to prove that PCG is not just a forest tool. I chose this topic because a lot of folks still think that PCG is just a forest creation tool. And that's mainly coming from the fact that PCG was first introduced with Electric Dream's sample project, where PCG is mainly used for creating a forest environment. Well, that's a great use case for PCG, but it's really just one of many. In this tutorial, we are going to build a smart tool for spawning wall-mounted props and assets using PCG. So without further ado, let's dive into it. In the first part of this tutorial, I'm going to show you how we can create the core PCG graph behind this tool. Then once we learn about that, we are going to see how we can make it more advanced and add more features to it. But before getting started, we have to make sure that PCG plugin is enabled on our Unreal Engine project. So to check that, I'm going into my edit menu and then plugins, and I will look for PCG. As you can see, procedural content generation framework is not enabled. So I'm gonna enable that, and you can see this restart now button is appeared down there, and I will click on that. Then we will wait for the engine to restart. And now we are back into the engine and I will look for PCG. You can see that procedural content generation framework is enabled now and we are ready to get started. So I'm going to create a new level. Choose the basic template. And then I got my new level, then I'm going to save that under the content folder, PCG tutorial, and then maps folder. I got already a bunch of other demo maps over there. I named this one demo PCG and hit save. Now I got my basic level here. As you can see, we already got a floor here, but we will need some walls so we can use them to spawn our props over them using the PCG graph that we are going to create. So from the shapes, I'm gonna drag a cube over here and then zero out the location. Let me also change the transform, the scale of it. Put this as 0.1, then I'll change the Y scale to 3 and x-axis is 3 probably, and then 90-degree rotated, so then take it a bit up. Now it's aligned to the floor and probably a little bit bigger, so it gives us more space. So this is the first wall that we have here. I'm just duplicating this one. This is the second one, or just also duplicating this one and rotating it slightly. So that's the third wall. So just imagine that we are in a space where we got bunch of walls in different directions, of course, in different rotations, and we want to spawn some props over them, like some light fixtures over them. So the next thing that I'm gonna do here is creating the PCG graph. For that, just because I like to keep things clean, I'm gonna create a folder here in my content browser, call it PCG, and then within that folder I'm going to right click, and from the PCG I will choose PCG graph. Immediately you will see that it's asking us to choose a template for our PCG graph. You can see a bunch of templates over here. Each one of them has a specific use case, of course, like we have some templates for spline, for textures, volume, for simple forest. Like the point of this tutorial, of course, is proving that PCG is not a forest tool, so I'm not gonna use the simple forest template. I will use the default empty template. I'll initialize from that template, and it will ask me to name it. I will name it PCG props. Then I will just right click and save. So now we got our PCG graph. I'm gonna double click to open that. It's opening in my other screen, so I'm just dragging that over here. Now you can see that we got an input node and an output node as well. So it's just an empty template where we can start adding our PCG nodes here. Before I start adding the nodes to my PCG graph, I think it's important and useful to learn about how PCG works. But I'm trying to explain it in a simple language. PCG works by getting or creating the world spatial data. But what world spatial data means here? The world spatial data is basically landscape data. If we have a landscape in our world, could be actors data like static meshes or whatever sort of actors we have in our world. Volume data if we have volumes, splines or textures data, or it could be also a point grid that we can create using PCG nodes. So once we got that data, we need to process it and translate it into form of points. So we are basically going to sample and process that data. And each one of those points that we got here in this step are carrying some sort of attributes. So in this step, we are able to modify those attributes and change them in a way that we want. And finally, we can spawn instances. So we are basically turning those points into some sort of actors or static meshes. So if we think of this workflow, in our case, first we need to get the walls or static mesh data in our world. Once we got that, we are going to define some design patterns, let's say like spawning the points only at a certain height or rejecting the floor and ceiling. And then finally, we are going to turn the points into forms of props or assets that we want to spawn on the walls. So with that being said, let's get back to our Unreal Engine window. Now I'm back to my PCG graph, and as we discussed earlier, I should start by adding the nodes that can get me the world spatial data. Like in this case, it would be the static meshes that I have here. So I'm looking to get the data of these walls on my graph. Let's see how we can do that. So I'm going to right click on my graph and look for one of the nodes that can get me the world spatial data. If I just type get, you will see a list of the nodes that can get you the world spatial data. Here I'm going to use the get actor data. Then I will click on that node, and under the details panel, you can change the properties related to that specific node. So as soon as you select a node here on the graph, you can change the properties under the details panel. Here I'm going to change the actor filter to all world actors. Then I have two options here for the actor selection. I will go for by class in this case. Later during this tutorial, I'm going to show you how we can use the by tag option, but for now I'm going to use the by class. Then once you selected the actor selection on by class, then you need to select the specific class that you are looking to get. Here I'm going to select the static mesh class, the static mesh actor class. Then while that node is selected, I'm going to press A from my keyboard to inspect the node. Immediately you will see a yellow circle here, and then you should check your attributes panel down there. And on the attributes panel, I don't see any data showing up here. So that means that get actor data node is not getting us any data from the world. And the reason for that is basically because we haven't added the PCG graph that we have here to our world. So I'm gonna just drag and drop the PCG graph there. And I will zero out the location of it and just move that up a little bit so it's not too much under the floor. Then I'm going to save my PCG graph and right click on the PCG graph that I have on the world outliner and right click and edit PCG graph. Now you can see the attributes names under the attributes panel, but the output of my node has only one index, so that means it's only finding one mesh for me. While I have more than one static mesh actor here, so I need to make sure that my node is getting all the static meshes that I have within my world. So I'm getting back to my PCG graph window, and I will select the node here and make sure to select multiple checkbox here. That's going to get all the static mesh actors in my world. As you can see now, I have 5 indexes here. That means I have 5 static meshes. The moment I'm selecting index 1, if I check my preview here, you can see that's the floor. Index 2 is one of the walls, and so on. So we got all the 5 static meshes that we have in our world. And as you can see, each one of these indexes are giving us thousands of points generated on the static mesh actors that we got in our world. Although I can use these points and filter them out for generating our wall-mounted props on the walls, but it's not going to be really efficient. All I need here is basically the attributes of the actor itself, like the rotation, position, and the other attributes that I got for individual meshes that I have in the world. In order to get that, I can change the mode on the data retrieval settings. So I can change it to get single point. If I change it to that, then you can see that each one of these output indexes are giving us single points per static mesh actor. And I have now 5 indexes, and each one is giving me 1 point instead of 5,000 points. So it's more manageable and more efficient. The next thing that I need to do here is to reject the floor. My second index is the floor, but I don't need the floor. So I can get rid of the floor or the ceilings just by a simple node called normal to density. And this is basically going to give me the points with a normal value that I can set here, and then sending this value to the density attribute of our points. I'm just reminding you that density is a value between 0 to 1, and it can be seen as the color of our points. So 0 is basically showing us a black color, and 1 is showing us a white color. So I'm going to set the z-axis to 0 because I'm only looking for the walls that they have normal value of 1 on y-axis. So after setting this value of normal, I'm going to inspect the normal to density node, and immediately you can see that right now my first index, which is the sphere, the sky sphere, turned into black, and then the second index is also turned into black, which is the floor. But the third index is a grayish color because this is basically the normal value that we have on that specific static mesh. Then we will check the other indexes as well. This one has a density value of 1, and then this one has a density value of 0.866. But here on our density attributes, I need to get either values of 0 for the ceilings and floors and 1 for the walls. For that, I need to remap my density attributes to values of 0 and 1. I'm going to use an attribute remap node here. I'm getting an error here. It's just because I haven't set the right input source there. I will set it to $density. Hit enter. Then I will set the minimum range to 0 and the maximum range to 0.1, something very small. So anything above 0 is going to be remapped into values of 0 to 1. And then I'm going also to clamp to unit range. So it's going to give me a clamped value between 0 to 1. And then I'm going to inspect this attribute remap node and see the values of density attribute on different outputs. I'm going to check the last index here. Now you can see the last index, which was 0.866. Now it's remapped to 1. So now we got all our static mesh actors, and we have density of 0 on our floor and density of 1 on our walls. So the next step is going to be adding a point grid on each one of these walls, and we can use those point grids for spawning our assets on the walls. To do that, I'm going to add a create points grid node to my PCG graph, and if I inspect that node, you can see it's giving me 100 points in the 3D space, but I only need 1 point. So I'm going to change the grid extent to 0 on all the 3 axes and keep the cell size on 100. So that's giving me only 1 point. And to preview that, I can simply make sure the node is selected and press D from my keyboard. So that's going to debug that node in the world for me, and you can see there's a cube over there with the dimension of 100 by 100 by 100 in the 3D space, and it's at 0, 0, 0. But I don't need that point over there. I need that point to be generated on my wall surfaces. And for doing this, I need to use another node. So I need to basically copy this point on all of these wall surfaces. For doing this, I need to drag off a wire from my create points grid node and look for copy points. So this node is going to copy the points that are generated here on my wall surfaces. So I'm going to connect the wall surfaces output here to the target, and then I will also change some of the settings of the copy points node. One of the settings that I need to change is the rotation inheritance. It's because basically I want all the points to get the rotation from the walls. So I'm going to change that and set it to target, so they are getting their rotation from the target, which is my wall. And then I will keep the rest of settings except this one, scale inheritance. I'll keep this one on the source because I want to keep the initial scale values of the points, and I will uncheck this checkbox because it's going to apply the target scale to the position values, which I don't need. The next thing, I'm going to debug this copy points node to see the result of it. First, I need to turn off the debug for the previous node, and I'm just minimizing this window. Hopefully I can put it somewhere so we can just see the result easily. I'm going to click on the copy points node and press D. Then immediately you can see now our points grid is basically copied over the wall surfaces, and this is exactly what we want, but this is just the core of it. The next thing that we need to do here is spawning the assets or props that we want instead of those points that we copied over the walls. So for that, I'm going to drag a wire off my output node and look for spawn static mesh. Sorry, that was spawn spline mesh. Spawn static mesh spawner. Then on this static mesh spawner, I'm going to add the mesh that I want to be spawned on the walls. So here under the mesh entries, I'm going to add all of those meshes that I want to be spawned on the walls. It could be one mesh or more than one. So I'll just click on the plus button here, and I will open this descriptor here. Then from the static mesh, I'll look for lamp, and that's gonna give me a wall lamp like this one. I'm going to choose this asset, and I got this asset from one of the projects on Fab, but you can feel free to add any sort of assets that you might have in your content browser and just use your own assets. So I'll release the debug from the copy points. Then immediately you can see that the lamps are now spawned over our walls, but I see some errors as well. Like I see a lamp is spawned on the floor, and we also don't see the lamps in a correct transform or rotation, let's say. So we have to, be able to control the transform of each one of these points, and we have to also get rid of this lamp. So first let's get rid of this one, but I'm also going to hide the clouds here so the sky looking cleaner to me. Let me get back to my PCG graph. I'm going to minimize this, put it on the side here so we can see the results right away there. Okay, so to get rid of this one here, if you remember, we already set the density of the floor and the sky sphere mesh to 0. So we should be able to now filter out the points with density of 0, just get rid of them right before this node. So right before getting into the copy node, I'm going to drag a wire of my attribute remap and look for density filter. This is very handy. I can just easily add it there, and I'm gonna disconnect this one and connect that to my copy points, and immediately you can see just it's choosing all the points with density above 0.5, so that's fine, and immediately we were able to get rid of the one which was on the floor. The next thing, as I mentioned, is having a control over the transform of each one of these lamps. So for that, I need to add a transform points node right before the static mesh spawner. So I'm going to look for transform points and connect it to my static mesh spawner, and then disconnect the previous connection, making some space here for that node. And on the transform point node, I should be able to define my rotation values, the correct rotation values for the lamp. So I'm going to set it for now by default to -90 to -90. Now they are looking upward. They should also be over the surface of the wall. Right now they are penetrating with the walls, so I'm going to add a little bit of offset on z-axis of the walls. I'm going to add like 12 centimeter, or maybe 12 is not that much. I'm going to add like 25, probably 25. You can see that the lamps, there's some gap over there, so probably 15 is good. No, actually 20 should be fine. Yeah, 20 is fine. So all the lamps are looking good to me on all the walls. And if I add or duplicate one of these meshes, it should detect automatically that new mesh. So I'm going to just Control D. As you can see, it's detecting, like, even if I rotate this mesh, it's still trying to match the rotation, and the lamp is going to be always spawned on my wall, not the floor. So this is really cool. But what if I want more than one lamp on these walls? For that, I need to change the point grid extents. So the bigger grid I have, the more points I will have on the walls, and more points means more lamps. So I'm going to change that on the x-axis, for example, to 100. So now I got more than one lamp. Now I have two lamps on each wall. Then let's say if I change it to 500, I'm getting like 10 lamps on each walls. And as you can see, the lamps are now spawned outside the walls, which is an error, and we have to fix that. And for fixing this error, I'm going to make a difference between the wall areas and the point grids. So let's see how we can do that. I'm going to just add a difference node here, and then I will make a subtraction the wall areas from it. So the source will be the output of copy points, and the difference is the wall areas. And then I will take the output of this node to here, connected to the transform points. And I'm going to change the density function to binary. Then let me maximize this window. Make some space here for these nodes. Trying to make it a little bit clean. Okay, so now we have our difference node already there. If I'm going to inspect it, you can see that there are different outputs on it, and this is basically what the difference node is giving us on one of the wall meshes. You can see the black parts are the areas with zero density, and the white parts are the parts of the wall that they have density of 1. These are basically the areas which are outside the wall mesh. And I'm going to invert this, so these parts are going to turn into black, and the middle part is going to be white with density of 1. So for that, I just need to do a 1 minus, and then define the input source as density. Then I'm going to connect that with that node there. Space there. Okay, now I'm going to inspect that again. Now you can see we have inverted the density on the walls, but let's preview that in the world and see how that works. You can see that we still have the lamps outside the wall surfaces. And the reason for that is because we still have those points with density of 0. We have to get rid of them. So I'm going to drag a wire from the 1 minus and look for density filter. This is going to give me the option to remove those points with density of 0. I'm going to sort out these, align them, press Q, so all of them are becoming linear. And on the density filter node, I'm going to make sure that keep 0 density points is unchecked. Then let me see how that looks now. You can see now we have only the lamps up to the edge of the walls, but this is still not quite what I want. I don't want to have this last lamp here on the on the edge of the wall, because that's not looking normal. So I'm going to get rid of that. For that, I just need to modify the bounds of the wall meshes. So basically I'm going to scale down the bounds of wall meshes a little bit, so I can get rid of that one last lamp over there. For doing this, I'm going to just add a bound modifier here. After the density filter here, I'm going to add a bound modifier, and then take that output to the difference node. On the bound modifier, I'm going to change the minimum bound to 0.8, and then max bound to 0.8. you can see it's kind of scaling down a little bit the bounds of the modifier, and now we got rid of that one last lamp over there on the edge of the walls. Like even if I move this, you can see the lamps are moving and spawning on the wall. I think I have to change the bounds a little bit again, like turn it to 0.8, 0.8 on Y and X axis as well, just to make sure that we don't have that extra lamp, or maybe smaller again on 0.7. Yeah, I think 0.7 is the right value there. So now I can rotate the walls, and you can see the moment I'm rotating them, we don't see anymore that of extra lamp over there on the edge of the walls. So now we got the lights on all of these walls, but if I change the grid extents on the y-axis to 100, then that will lead to this kind of situation where we have lamps on the on a vertical columns, and then this is not a desired result. So we should make sure to add a rule or some sort of logic in our PCG graphs to avoid this situation. Let me get back to the graph. So right before my spawner, I'm going to drag a wire from the transform point and look for filter attributes by range. Then I will enter the attribute name for the target attribute. So I will use the position Z this time, position Z, to make sure that you are entering the exact same naming that you see here. I'm going to use this attribute and try to filter the points based on the position Z. Then I'm going to connect inside filter to the spawner, and here I will make sure that I'm checking the use constant threshold for both min and max. So this is going to define a specific height range for placing our lamps. This is going to define the specific height range for our points. We can say that any points lower or higher than this specific height range. This is going to filter out the points based on their position Z. So any points lower than this minimum position Z will be ignored. I can set that to 100 centimeter, and then the maximum threshold can be 300. Let's see how that looks. You can see now, we are not seeing anymore the first row of the lamps. It's just because I defined the minimum height for them. So I can change this, let's say, to 20. If I change it to 20, so that means that it's going to again bring back the first row. If I want the first row but I don't want the second row, then I'm going to reduce the maximum height. For that I can set it to 200 or maybe 100. Yeah, that's the right number. So now we can see that we have the lamps only spawning on this specific height range that we already defined in our filter node. As a final step for this part of our tutorial, I'm going to expose all the required parameters for this PCG graph so we can change them directly from the details panel without the need to open the PCG graph and mess up with the different nodes there. And this is going to turn our PCG graph into a reusable tool that can be just dropped into any world and spawn any sort of static meshes on the different vertical surfaces. So let's get back to our PCG graph, and the first parameter that I'm going to expose here is going to be the grid extents. This is going to allow us to control the number of points generated on this create points grid node. I'm going to just drag it a little bit to the left and then click on this arrow button. Now you can see all the available inputs on this specific node. For now, I need the grid extents, and if you hover your mouse over that, you can see it's a subtype of vector. So I'm going to add a new vector parameter to my graph parameters panel. If you don't see this panel, you can enable it from window and then graph parameters. For adding a new parameter here, you can just click on this plus button, and then immediately you will get a new float parameter. Then by clicking on this arrow, you can change its type to vector. And if you click on the name, you can change the name of this parameter. I'm going to set it to grid extent. Then I'll just drag this parameter to my graph and connect it to my grid extent. And the next thing that I need to do here is calculating the cell size, but I can do that only if I have the number of the points. So for that, I'm going to add a new parameter here and change its type to integer. Change the name. Then drag and drop it on the graph. And now that I have this grid extents and instances count, I can easily calculate the cell size just by dividing the grid extents by the number of the points or the instances count, and then multiplying it by 2. So I'm going to drag a wire off the grid extent and look for divide node. And then I'm going to connect the instances count to the divide and drag another wire off the divide node and look for multiply this time. I'm going to multiply it by 2 and drag a wire from the output of the multiply to the cell size. But immediately you can see there is a warning that says cell size must not be less than 0. And the reason for that is the default value for the grid extent should be always 1, 1, 1, like shouldn't be 0. So I'm going to set it to 1 by default for everything. And immediately you can see the warning is gone. And now we have the ability to change the grid extent and the instances count from the PCG graph under the details panel. So if you click on the PCG graph under the parameters override, I'm going to enable the grid extents and the instance count. Then I will set some values here. I'll change the x-axis of the grid extent to 100 and the instance count to 5, but I can't see any lamps over my walls. So the reason for that could be the height filter that we added on the PCG graph. So I'm gonna adjust the height filter that we added before the spawner. So I'm going to change the max height to 300, and immediately you can see that the lamps are appearing on the walls. Now we have 5 lamps spawned on each wall, but if I want to change the number of the lamps, I just change the instance count to, let's say, 3, and there you go, you got 3 lamps on each wall. If I set it to 1, it will give me 1 lamp on each wall. So now we are able to change the number of the lamps on the walls without the need to open the PCG graph, and we can simply just change the instance count parameter to whatever number that we want. But I haven't yet exposed the transform parameters for the lamps, so we can move them around on the wall or change the scale of the static meshes. So let's get back to the PCG graph, and I'm going to click on my transform points and extend the node using the arrow button there. Make some space here. So I'm going to add some parameters for the offset, rotation, and scale. For the offset, since it's a vector, I'm going to add a vector parameter here and change the type to vector. Just change the naming to position offset, or maybe pose offset to make it short. Then I'll need another vector for the scale. Change the type to vector to scale. And set all of these, set the scale probably by default to 1. Then I'll need another parameter for the rotation and change the type to rotator. Name it rot offset. Drag all of 3 on the graph. Then I'm going to drag a wire from the position offset to both min and max. And from scale to scale min and max. Then from the rotation to rotation min and max. Now I got parameters for offsetting the position, the rotation, and scale, and I can change those parameters directly from my PCG graph under the details panel. As you can see, if I enable the rotation and just change it to -90, I'm getting the default value that I had it already hard-coded on the node. I can change the rotation offset to -90. I already had it hard-coded to the node, so I'm going to set it now here. So the lamps are looking good to me. The other parameter that I had it hard-coded on the node was this one, 25 on the z-axis. So this is going to, put the lamps over the walls and overlap them there. I can change the scale of the lamps by changing the scale parameter to 0.5, or if you want bigger lamps, you can go over that, 1.2 for example, but this is too big. I think 0.7 is fine. So now we got one lamp on each wall. If I want to change the number of the lamps, I will just set it to 3, let's say. We got 3 lamps, or maybe 4 lamps here. And as you can see, I can also change the grid extent, to make more space between these lamps. I'll set it to 200, for example. So now we have more spacing between the lamps. And the last thing that we need to expose here is the lamp static mesh. So we can change it to any other type of props or static meshes that we want to spawn on the walls. For that, I'm going to get back again to my PCG graph. Then I'm going to select my mesh spawner. And our static mesh is located under the descriptor. So I have to expose this static mesh parameter, but currently in PCG, there are no ways that I can directly expose this parameter. So if I even extend the node, you can see there are no available inputs for that, so I can expose it directly on the node. but there is a workaround for that. And the way to do it is adding the static mesh path as an attribute to the points and then changing some settings on the static mesh spawner node. So I'm going to drag a wire of the filter attribute right before the spawner and then look for add attribute node. Then we are going to change the output target to a name that makes more sense, because this is going to be the name of the attribute. So I'm going to change it to spawn mesh. And then hit enter there. For this input here, I'm going to add a static mesh parameter on the graphs parameter panel and change its type to static mesh. Then from the static mesh, I will select the object reference. Then I'll make it an array parameter so we can choose more than one static mesh. I'll change the name to static mesh meshes. Then I'm going to drag and drop it over the graph and connect it to the attributes here, and then connect my outputs to the static mesh spawner. You can see a warning here, and the reason for that is because we don't have any elements on our array. So I'm just adding an index to my array, and then immediately you can see the warning is gone. Then what we did here was adding the spawn mesh attribute to our points, so they know which asset they should be looking at for spawning on our static mesh spawner node. If I inspect my add attribute node, you should see the spawn mesh attribute already added on the attributes. So if I just change that to a different mesh, you can see it's empty right now because I don't have any mesh here. But if I set it to the lamp mesh, you can see immediately that attribute is getting filled up with the proper input. Then the next thing that we need to do here, since we are getting the spawn mesh there, the attribute is already there, the next thing we need to do here is changing some settings on the static mesh spawner. So we are going to change the mesh selector type to PCG mesh selector by attribute. Then we will enter the attribute name. The attribute name should be spawn mesh because we have the mesh reference over there. Then I'm going to change this mesh to a different mesh, probably like a clock. I think I had it there. I'm gonna change it to the clock base, and I will just minimize this PCG graph, and immediately you can see now instead of the lamp I'm getting a clock there. So from now on I can change the static mesh parameter directly under the details panel of my PCG graph, and choose any other type of mesh that I want. I will probably this time look for a cloth hanger. Let's say if I have one. Okay, this is my cloth hanger there. I will make it bigger a little bit, like 2. Okay, and then I can add some position offset on Y axis of that's a local Y. Be careful with the numbers, like 20. I'm gonna put -50, so it can be higher, or you can have actually more than one mesh there. I can have a clock there as well. Then I will need to increase the grid extent so the spacing between them is good enough. So I will change it to 300. That's probably too much, like 250, and change their scale to 1. So now I got a clock and a cloth hanger on each one of the walls without the need to hand place them or manually adjust their position. So this way, using PCG, we were able to build a pretty handy and reusable tool that can be added to any other level and spawn our wall-mounted props or assets. Then we can change their parameters, like transform parameters, their quantity, the spacing between them, or even the type of static meshes that we want to spawn on those walls. And finally, before saving my PCG graph, I'm going to get back to it and change this clock pace to lamp, because I like lamps. So I'm gonna save this PCG graph. As you can see, it's immediately detecting the walls and adding the lamps on them. But this was a very basic level that we built together just to show you how we can build this PCG graph. Now that we have the PCG graph, I'm going to test this tool in a more complex level that I got from Fab. So I'm going to my maps folder and opening the other demo level that I have. First, it's asking me to save this one. So here is my office space demo level that I got from Fab. It's fairly complex, and it's a good place for testing our tool. So I'm getting back to my PCG folder and just drag and drop the PCG graph that we've built together, and immediately you can see that we got the lamps on all of the vertical surfaces that we have here in this level. So that's an expected behavior because I'm checking the mesh normals to see whether this is a vertical surface or not. But probably I don't want to get the lamps on these bars or these columns here. I only want to get the lamps on this kind of walls between the columns. So to fix this issue, instead of getting all of the walled actors data and then checking their normals to see whether they are a vertical surface or not, I need to use a better way where it can detect only the actors or only the wall surfaces that I want. And this is exactly where the tagging becomes really useful and handy. So I can assign some actor tags only on the walls or the surfaces where I want to get the props on them, then get the data only for those actors on my PCG graph. I've just selected all of those actors, and then I'm looking for tag on the details panel. I'll add a tag here, name it wall. Then I need to open my PCG graph. And here on my PCG graph, I'm going to disconnect these three nodes where I'm checking the static mesh normals. I'm gonna disconnect them, put them aside. Then I will connect the get actor data node again. And I'm going to change some of the properties of the get actor data node. So the actor selection, I will set it to by tag. And the actor selection tag, I'm going to expose this one actually because I need the user to be able to change the tag on the details panel. So I'm going to extend this one and probably get rid of these before. You can see there is an actor selection tag input here, and it's a subtype of name. So I'm going to add a name parameter here, change the parameter type to name, and change the name of the parameter to selection tag. And then drag and drop it to my graph and connect it to actor selection tag. I can also set it by default to wall, so it will look for the walls by default. I'm going to save this one and minimize it. And right away you can see that the lamps are now only spawned on the surfaces that they have the tags. Next, I'm going to change some of the transform parameters of the lamps so they look better. I'm going to select my PCG graph, and I'm gonna change the rotation offset to -19 so they look upward, and then I change the position offset to 25 on the axis, and now they are looking much better. And I think they are a little bit big, so I'm going to change the scale to 0.75. And I think 25 is too much, so I'll set it to 20. And we got our lamps only on the surfaces where we assigned the tags on them. I can also change the number of the lamps like I did in the basic level. So I'm going to change the instances count to 3, but for that I also need to change the grid extent to 100 at least. So you can see now I'm getting 3 lamps on each wall, and I can control the spacing between them using the grid extent size. So now they are closer to each other. I'm getting the lamps on all of those surfaces that I got the tags on them. I can also change the static mesh that I have on them. I can change it to the clock like I did on the other level, clock base, but I don't need 3 clocks, obviously, only 1. So as you can see, now I got the clock on all of the walls where I got the tags on them. And if I wanted to add a clock and a lamp, I can add another static mesh to my static mesh array. Like I will add a lamp here, and then change the instance count to 2, and then add some spacing between them to 200, changing their scale a little bit. Sorry, that was too much. So now I got a lamp and a clock on all of the walls, but if I don't want the clock, obviously I can just delete the clock and I get 2 lamps over there. So I was able to reuse the same tool in a more complex scenario, but here I'm using tagging instead of normal detection. And even if we are going to duplicate these walls, we are getting the lamps again on them. So as long as we have a mesh with the wall tag, we will get the lamps on them. Like, it doesn't matter if you even rotate it in any direction, you'll still get the lamps, and you would be able to change the properties of that, like getting 3 lamps or 4. Then another thing that you would be able to do, you can just drag and drop another instance of this PCG graph, and then assign a different type of prop on that. Let's say this one will be the class hanger, and then it's going to add a class hanger. We will be able to change the Y offset of it to 50 and change the rotation to -90, and adding some offset on Z space. Now I was able to quickly add this class hanger on all of those wall meshes without the need to go there and transform and hand place it. You can also scale it up a little bit to 2. You can see that now I got these hangers on all of the wall meshes. I'm going to delete this one. We'll just need to regenerate, clean up and generate. So cleaning up the cache, and then now I'm getting the hanger and the lamps on all of these walls. As you can see, using the power of PCG, we were able to build a pretty handy and reusable tool for spawning assets and props on any sort of surface that we want. And finally, we can say that PCG is not a forest tool. At the end, I want to thank you for following, and hopefully this was a useful tutorial for everyone. See you soon.